Hey class, so some of you have been asking about the last problem on the homework number 96 from chapter 2. So I thought I'd make a short video to give you guys some pointers about what is going on just to make sure you can understand and hopefully work towards the correct solution. So in this problem, the situation is there's a person that's going to be dropping this ball. It's going to fall some initial distance, which I'm going to call D1, which is given to us in the problem statement. In my problem, it's 7.65 meters. It then enters the water and continues to move an additional distance at D2 before reaching the bottom of the pool. Okay? And that whole thing takes some overall time that we're given. In my case, it's 6.16 seconds, which I will call capital T for the total time to reach the bottom. And with the total time, capital T, you can think of it as being broken up into two pieces. Alright, so you can think of there being some T1 that it takes to get to the surface of the water, and then another time T2 that it takes to get from the surface of the water to the bottom of the pool. Alright, so let's think about what we have going on here. For example, let's consider the velocity. Alright, so we know that our initial velocity up here when we start is 0 meters per second, right? Then the ball moves down, accelerating until it gets to the water. Once it hits the surface of the water, it has some velocity, which I'll call v1, and then it continues with that same constant velocity, v1, all the way until the bottom. And so with that in mind, we can learn or make note of the acceleration. During the free fall portion, while it's traveling through d1 in time t1, our acceleration is going to be negative g, negative 9.8 meters per second squared. When in the water, our acceleration, since we have a constant velocity, is 0. Okay, so that's the setup. We're given t, capital T, and d1, and we're asked to find some other things. So what are we asked first? First, A asks us how deep is the water, or the lake. I guess it's not a pool, it's a lake. So what is D2? Okay, well, in thinking about D2, my first thought is, hey, let's use our equation of motion. We know that x final equals x initial plus v initial times time plus 1/2 acceleration times time squared. Okay, so we know, let's see, for D2, we know our acceleration is 0, so that part goes away. And if I move this over, x minus x initial, the distance traveled, that's just d2, is equal to the initial velocity in the water times t. So rewriting this in terms of our variables, we know that d2 is just going to be equal to v1 multiplied by the time that we spend in the water, which we called t2. So this equation here can be used to find the distance, or the depth of the lake. But in order to find it, we need to know V1 and T2. Okay? So, V1, I trust that you guys can figure out just using your equations of motion and the free fall portion. So again, use just this section to find V1. And T2, notice, the total time T is just T1 plus T2, and you know the total time, and so if again you look at this section, the first half, you can find the time it takes for a ball acting only under gravity to travel a distance of 7.65 meters, and therefore you can find T2. So I hope that helps you guys get started. Some of you have gone down close to the right track, but I think it's been a little confusing for you all. Second thing you need to do is consider part B. Okay, part B, it asks, what is the magnitude of the average velocity? So we know average velocity, that's a V with the average sign. Okay, I'm just going to erase that and rewrite it because it's ugly. So we know average velocity is just equal to change in position over change in time. So in this problem, what is our change? Sorry, just trying to create some new blank space here. What is our change in position, and what is our change in time? Well, when it wants it for the whole trip, we need to look at the distance traveled for the whole trip. So that's going to be d1 plus d2, the total distance traveled, And the time, again, is going to be the total time, capital T, which is T1 plus T2. And so again, once you get to part B, you should be able to relatively easily find the average velocity. Okay? And then the last thing it asks you about in part C is if the lake were drained, how long or what initial velocity would the ball need in order to reach the bottom of the lake. So this one, in some ways, is a simpler problem. What it's saying here is you still have the person standing on the diving board, but now you have the ground and no water, and so you want the ball to travel the same distance and take the same amount of time. But since the acceleration is going to be constant this whole time, you're going to have the acceleration of negative g during that whole portion. What that's saying is that you're going to need the ball to travel a larger overall distance because it would take less time without the water in the way to get down. So what's going to have to happen? Well, you're going to have to throw it up and then it's going to have to come back down. So what initial velocity do you need for it to take the same time to get to the ground? Keep that in mind, and again, use your equations of motion to try to solve for that initial velocity. And as you can see in my drawing, your hint is that it should be a positive value. Alright, I hope that helps. Best of luck, and have yourselves a great night. I'll see you all tomorrow.
Bye.
Bye. That's my wife.